At A, are we looking at B, or are we looking at both?
A.
A, very good. So today is the second. Good. So we have limit as x approaches infinity from the square root of x squared plus 4x plus 1 minus x. Very good. Every time I'm asked to find the limit, I do what first? Aisha, say it again. Yes, so I'm looking at it and I'll say, okay, let's see these two pieces, where are they going? As x approaches infinity, where will this go? Or let's say just the inside first. Where will the inside, forget about the square root for a moment. Where will the inside go? Which of these three terms is the most powerful? The other ones are much influence less, much less. X squared. So where does x squared go as x approaches infinity? Infinity, very good. What about the square root of infinity? Still infinity. What about this? Where will x go? Good. So then we know what case this is. What case is it? And how do we call it? Excellent. It's an indeterminate case. Very good. So it's infinity minus infinity. Nobody knows what this is. Good. It's an indeterminate case. Good. How do we approach this then? Oh, many of you did it correctly on the test. Oh, Johnny?
Thank you.
Can you do this?
Okay, thank you.
Sure. Okay, so how do we address this? Anyone? Ben, what did you do? Of course. So what do I rationalize it by?
Square root of x squared plus 1 plus x over 7.
Very good. Excellent. What next?
Y x over the integral of x inside the x squared. Now it's left with
We have an agreement on this, right? So it's a minus b times a plus b. We signed an agreement at the beginning of the class. So what is that?
minus x squared.
Very good. A squared minus b squared, correct. I copied the denominator. Excellent. Good. You're right. These two go away. And then how do I think about this and what do I have to do?
I factored x out of the
Right. So not yet. Let's not jump ahead. Okay, for now, I'm going to keep it inside because I need a discussion there. And the numerator is still 4x plus 1, and I can go ahead and do what to it? What is the degree? Yes, so I will factor out.
x.
Perfect. Excellent. Good. So let's see. And I have to keep x. I haven't done anything to it just yet. Then, can anyone help? Charlie, you want to try? How many terms will I have in here?
2.
Okay.
4 plus 1 over x.
Very good. We all agree with 4 plus 1 over x. Is this acceptable? Yes? No? Agreed? Okay, because 4 times x is 4x and 4 times 1 over x will be 1. Perfect. Now what do I do inside here? What is left and how many terms?
4x plus 1.
So it's 1, right? 1 plus,
Plus what?
not 4x. If I write 4x and I multiply by x squared, I will get 4x cubed. So I have to be careful.
Oh.
4 over x, I agree with that. And then finally plus. Hi, Ian. Are you okay? 1 over x squared, indeed. Very good. Okay. So next, think for a second. I need to give Ian the handouts. And these flyers, take one. See if you are interested in any of that. And I'm looking for your test, and that's what we are doing now. Thank you. Okay, so we're back. Next. Limit as x approaches infinity. I want to congratulate everyone for not dropping the limit operator till the very end. I'm very happy to see that. Very good on the test. I'm really happy. Good. So then limit as x approaches infinity. What happens next?
Don't the x's cancel out?
Not yet. I'm not there yet. You're way ahead of me. So what do I do next?
Factor x out of v1.
Yes. However, I have to think. Because we know the square root of x squared is,
X.
careful. Exactly. In other words, it's the absolute value of x. So this answer will be x because x approaches infinity. Otherwise, it would have been? Otherwise, it would have been? You already said it. Exactly. If x approaches negative infinity. Good. So now I'm safe. So I will factor out the x instead of absolute value or negative x. It's positive x, correct? And I have 1 plus 4 over x plus 1 over x squared plus x. The numerator stays. And then what do I do? Exactly. This x and this x, they're common factors, correct. So limit as x approaches infinity, x, 4 plus 1 over x, and I factor out x. What is left in brackets? You can use parentheses, of course. What is left? Well, I have the square root, right? 1 plus 4 over x plus 1 over x squared, and then plus what? Indeed. Okay. What happens next? Thomas?
Cancel out.
Very good. I simplify x. What if x is 0? Can I simplify? Well, look where we are. We're far away from 0. There is no risk that x is 0. I'm sorry? This is number 10 on the test. 10a. Okay, so now I'm quoting a theorem that I will be using. Which theorem am I talking about? I need to use a theorem now, and we talked about it. What theorem is that? That limit as x approaches infinity from 1 over to the whatever. Yes? Yes. Of course, r is a natural number and so on and so forth. Conditions are there. So now I'm ready. So then what happens? What is this? Where is this going? Very good. Where is this going? Only because x approaches infinity. Right. Where is this going? Good. So then what is left at the top? After all the zeros go away, what is left? 4. What is left in the denominator after all the zeros are gone? 2. The square root of 1 is 1. 1 plus 2 is 2. Final answer? 2. Okay, what do we conclude? Every time and here's your hint. Every time we find the limit as x approaches infinity or negative infinity, and that is a number, what does that mean? I already gave the hint. Anyone?
Horizontal.
Very good. But I have to be very specific now because I did use this in my calculations. I cannot say everywhere. What can I say? That y equals 2 is a horizontal asymptote at only infinity, yes. Yes. I did use the fact that x was approaching infinity. How are we doing on this? Is this clear? It's a lot of work. A lot of steps, a lot of work. First I had to identify Secondly, I had to rationalize. Then I had to know how to factor. Then I needed to know to remember what am I taking out of the square root. Then I had to factor again, the greatest common factor. I had to simplify, and then I had to quote my theorem that I'm using. And in this case, and so on and so forth. Questions? Is this okay? Anything else? I will post solutions for you to look at in preparation for the final exam and everything. So you will have detailed, but if there is anything else that you want me to go over, let's do it. Anything else? Anything else? Anything else? Well, I prepared this handout for you because when I finished chapter 2, I said to you, what have we studied in this chapter? And then I said, not much. We just played with the difference quotient. Which is not really true. Look at how much. This is a summary of everything we did in this course in the last 5 weeks, which is a lot. So I would like to, till the end of the semester, talk about 1 or 2 topics, 5 minutes, and review every time we meet, and say, okay, I reviewed this and it's right there. Every time we pick something else from here to review. So let's look at this, and you put your finger on one thing, and we'll review it quickly before we move on. This is everything that we covered up until before the test. Everything. So pick a topic to discuss for a couple of minutes, and then we move on. And we'll do that every time we meet. Also, we promised that to meet next Tuesday, not tomorrow, right? In this room to make up for Labor Day from 4:15 to 6:15. Is that okay with everyone? I know Thomas cannot make it. Can you make it? Nestor, you cannot make it? Thomas? No. 2 people cannot make it. Will you watch the videos that I'm posting?
Yeah.
Okay. You cannot? Okay. And nothing else works. We talked about Saturday, that doesn't work. Friday doesn't work.
Yeah, I can do Saturday. I can do Saturday.
Who cannot do it? Meet on Saturday. Thomas, you can meet on Saturday?
Yeah.
You cannot meet on Saturday. You can? So 2 people. Okay, we'll talk about it. Let's not waste time now. So we'll talk about it again on Wednesday and make a decision. Okay, ready? Any topic from here? Okay, I'll pick a topic then. So we talked about the limit. We did not prove this other than looking at the graph, if you remember. But we will very soon. In this chapter, actually, we will prove this and why limit as x approaches 0 from sine x over x is 1. And the multiplicative inverse of that. But also what is important here is this. This will always be 1 as long as all these 3 boxes are identical and the box under the limit operator approaches 0. So this will always be the case. Okay, so we'll come back to this as well. Now the squeezing theorem, you had a problem. I did not say, and Charlie caught me, I should have said, use the squeeze theorem to show blah, blah, blah. Charlie was very smart, and he just plugged it in and showed me that it was 0. So I had to give him credit for that. But I will be more careful next time and write, you must use such and such, or do not plug in numbers. It's not a method that I can accept on a test. Okay? So that was I was expecting you to use the squeeze theorem on number 1 on the test. Okay, you identified correctly, and I was happy to see that when a function is not differentiable, right? A function fails to be differentiable at a point if it is not continuous, if it has a cusp, or it has an infinite tangent at that point. Not everyone remember that, but most of you did. Also remember we talked about this. Differentiability implies continuity. The converse is false. And here is an example. A function can have a cusp or can have an infinite tangent, which is continuous. A function is continuous if it has a cusp or an infinite tangent, but it's not differentiable there. So please remember that. We have two definitions for f prime of a. So this is one definition for f prime of a, and this is the other definition for f prime of a. But we do have one definition for f prime of x. Can anyone remind us what f prime of a means, or what f prime of x means? And with that, we can continue. So what does f prime of a mean? In your own words, how will you explain it to someone? F prime of a is...
It's like finding a derivative at a point.
Exactly, the slope of the tangent line at that point, or the rate of change of the function at that point. Perfect. So what will you say about f prime of x then? What does f prime of x mean?
It's like a slope of a tangent line.
Yes, but it's a function. Yes, f prime of a is a number, but f prime of x is, a being a number, of course. F prime of x is the function that will give what? The slope of the tangent line, or the instantaneous velocity, or the instantaneous rate of change at any point where the function is what? And you cannot say continuous, but you have to say where the function is. Say it again. Differential. Correct. Yeah. Thank you. Okay. I think with this, I would like you to go through all these. So here's the theorem that we just used a minute ago. This is a super important number 9 on page 4. Super important theorem. We did use it. Can anyone remind us when we used this theorem of swapping operators? We did use the swapping operator for continuous functions theorem. When? Can anyone remind us? We used it a couple of times. On what? I'll give you a hint. What was this? Just 0 or a. Let's put a. Of course, f of x is continuous. It has to be continuous for what to happen? How did we determine this? Exactly. So this was in the limit laws. Okay. F of x as x approaches a. Of course, under certain conditions, right? Because it's a square root and so on and so forth. I just wanted to identify one situation in which we use the swapping operator theorem. The intermediate value theorem, you correctly used it on the test. I was happy to see that. You correctly used the precise definition of the limit. I was happy to see that. It was we had one problem with the epsilon delta definition. I was happy to see that. And I would like you to, next time, pick another topic to start the class with from chapter 2, so we have it constantly fresh in our memory. Okay? Anything else? Anything else? Okay, so here's our handout for today and for Wednesday. So there are 2 sections together, 3.1 and 3.2. I can't really separate them. They go together perfectly. Okay. So I'm sure you'll be finally happy to look at differentiation rules. F and G are differentiable functions. C is a constant. N is any real number. So let's go through these. You can say at any point in time, stop, I want to see a proof of this or that. I also have a list of few things that I would like to prove with you, but we don't have to do all of them. So 3.1, and 3.2 together, derivatives of polynomial and exponential functions, and the product and the quotient rules. So let's start with f of x is a constant c, and I want to find the rate of change, the function that gives the rate of change of a constant. How fast does a constant change? Nestor, you want to say something?
No.
Okay, sorry about that.
Don't change.
There is no change, of course. The rate of change of a constant is 0. Constant does not change. Very good. So let's say now a constant multiplied by a function, prime. What do you think this will equal to? Remember what is f prime again? Let's go back to our handout. And let's identify f prime of x. What is f prime of x again? I need this to come back all the time to chapter 2. So what does f prime of x mean? What is it? Yes, it's the rate of change and so on and so forth, but what is it? A what? A limit. So f prime of x is a limit. Okay, perfect. So then we had before a constant multiplied by a limit. So what did we do? So what do you think this will equal to? Right? We had a limit of 5 times x when x approaches 2, and we wrote 5 times the limit of x because the limit of x exists when x approaches 2. The conditions are fulfilled, so we brought 5 in front. So just mimic this and tell me what to write. What do you think? Times f prime of x, that's it. In case you're thinking about the product rule, there is no need because the constant prime is 0. Is that what you had in mind? Yes, there is no need because that's a constant. You're way ahead of me, that's wonderful. So now I want f of x plus g of x. Remember the derivative is a limit. What did we do with, I did not put all the limit laws here, the 11 limit laws. I did not put them in because I was lazy. So, but because I'm assuming that those are already embedded in our brain. So just imagine that this is a limit of a function plus another function. So what will this equal to? F prime of x plus g prime of x. Of course, if I have minus, it's also minus. So they can go together. Good. Next one. F of x equals x, and I want to find f prime for f of x equals x. What type of function is x? Linear, very good. So what is the rate of change of this function? 1, indeed. The slope of x is 1. So the derivative of x is 1. Very good. Now, here are 2 rules. One of them is the product rule, and the other one is the quotient rule. I can just write down what they equal to, or we can choose to prove one. You know me, I don't really like telling you, hey, memorize this. So we can prove one of them. Would you like to prove one of them?
Let's try.
You want to try the product or try the ratio? Okay, it's fine by me. The ratio will kind of include the product. So the ratio is a little bit one step further than the product. So you're gonna see the difference, minor difference. Of course, the ratio has a denominator, but the product doesn't. Okay, so let's choose. Again, it's up to you. Okay, so then we want to find f over g, and I will not ask you to come up with this proof or any other proof for this. But I think it's good to at least prove one or the other. Okay, so f over g prime, so far I only know what? How do I find a derivative prime, a function prime? What is the only way I know so far? Exactly. Very good. What is the definition? I can go back to my handout. It's right here. We can never forget this as we move forward. And tell me what to write. Yes? Very good. Very good. F of x plus h, g of x plus h over minus f of x over g of x. Excellent. Divided by? Very good. Do we all agree with this? This is a function that consists of a ratio of two functions, f over g. So what do I do next? Here's your hint. Here's your hint. What do I do? Very good, which is? Are we all in agreement with this first step? Okay, now I need adjustments for the top. So what are the adjustments for the top? What does the top of the first fraction need? What does the top of the second fraction need? Good. Now can anyone dictate the numerator, please? So it's this product. I'm going to write f of x plus h times g of x and minus f of x times g of x plus h. Are we in agreement so far? Everyone? Are you with me? Yes? Okay, next step. This is h over 1. I'm going to flip the denominator. So this is my page 3. Limit as h approaches 0 from f of x plus h times g of x minus f of x times g of x plus h divided by h, g of x plus h. Okay. I have a question before we proceed. If I have, let's say, a over b, could I write a minus x plus x over b? Is that okay? Because negative x plus x will give us 0. So if you want, I'm adding 0 to a in the form of negative x plus x. Would you agree? Let's say I also have a y in here. So then I have a minus x plus x over b times y. So far, so good? Okay. Now, tell me if this is acceptable to you. A minus x over b times y plus x over b times y. I split the fraction into two fractions, a minus x over b and x over b. This fraction and this fraction. And then I distributed y in both cases. Is this step acceptable?
Yeah.
Yes? Ian, are you okay with this? It's okay if you say no, and I'll go back. Is a the same thing with a minus x plus x? Can I rewrite this fraction, a minus x plus x over b as a minus x over b plus x over b? Since I also have a factor outside, can I distribute the y in here and in here. So I'm distributing it to the first fraction, and I'm also distributing it to the second fraction. Is that better? I need this procedure up here, and you will see in a minute why. So are we in agreement so far? Other questions here? Okay, so let's continue then. So I'm going from here now, here. So I have limit as age approaches 0. So I'm going to do this, or apply this treatment to f of x plus h. And you'll tell me why. I want you to tell me why. X plus h, yes. And plus, and I want minus first. Minus f of x and plus f of x multiplied by g of x. And then minus, I ran out of room, minus f of x, and I'm going to apply the same treatment to g of x plus h minus g of x. I'm going to have to write it one more time because it's not clear. So I'm going to write f of x plus h minus f of x plus f of x. That's my negative x and x that I gave you here as an example. And then multiply by g of x, and then minus f of x, and then g of x plus h minus g of x and plus g of x, divided by h, g of x plus h. So what did I do? Really nothing yet. So I have a negative f of x and a positive f of x, which is 0. I have a negative g of x and a positive g of x, which is 0. Like I did before, I'm going to distribute g of x here and g of x here. I'm going to distribute f of x here and f of x here. So this is limit, as h approaches 0, from f of x plus h minus f of x times g of x, and then plus f of x g of x minus f of x multiplied by g of x plus h minus g of x, and then plus g of x, but multiplied by negative f of x, so negative f of x g of x. Everything over h, g of x plus h. I know you can see what I'm getting at and what I'm trying to do. Okay, so notice what happens here. Can anyone tell us what happens to these two terms? Correct. They go away. Okay, we're almost there. So this is limit, h approaches 0. So now I'm going to do this. F of x plus h minus f of x. I'm going to bring this h back up. And then minus f of x, g of x plus h minus g of x divided by h. Now I would like you to look at this and say, I see now. What are you trying to do? I want you to tell me what is the limit of this as h approaches 0. Where does this go? And I want you to tell me what is the limit of this as h approaches 0. Where does this go? And before you say anything, I'm going back to chapter 2. I'm not going to point. I just want you to tell me what it is. Exactly. And? Exactly. It's not done yet, though, because this is gone because it's f prime. This is gone because it's g prime. Nothing else at the top has h in it, but there is an h in the denominator. So I would like anyone to give me the final answer. Now I can drop the limit operator. When I write the final answer, the limit operator goes away. Thank you so much. It's done in the same way with the product. Just there is no denominator. So I prefer this order. Your book does not prefer this order. So I would like to finalize the quotient rule. First function over the second function. You choose the method you like. I'm fine with both. But I prefer this order. First function prime times the second function minus the first times the second function prime, oops, I meant prime, over the second function squared. Your book reverses these two, which is the same thing. 1 times 2 prime is the same with 2 prime times 1. So you can write it also as 1 prime times 2 minus 2 prime times 1 divided by 2 squared. It's up to you. Use the one you like. So we're back to the handout. So you can fill it in the way you like. Either f prime g minus f g prime over g squared, like you see it here. Or you can fill it in as f prime times g minus g prime times f over g squared. It's up to you. The product is very similar to the numerator. It just has plus in it. So please fill it in. F prime times g plus, it's up to you if you want to write g prime times f or f g prime. Yes, Ian, go ahead. The product has, yes, the ratio has, yes. So f prime g minus f g prime divided by g squared. It's up to you if you want this or the other one. I'm fine with both. Okay, finally, x to the nth. I would like to look, before we conclude, about x to the nth, which is not the mathematical proof, but I would like us to use the definition on x cubed, and we already did this. It's done already. We just did it. Derivatives of exponential functions are next, but I would like us to use the definition on x cubed. I would like us to use the definition on the square root of x, and I would like us to use the definition on 1 over x. So I wouldn't say this just one last time, but so our f of x equals x cubed. So I want us to determine f prime. How do I determine f prime? Back to chapter 2. How do I get f prime? Say it again. No, but you want the shortcut? Before we will conclude in a second. So let's use a definition on this one. Limit, very good. S, very good. SH approaches 0 from, very good. Minus, very good. Over h, good. Anyone remembers how to cube x plus h to the third power? Pascal's triangle, maybe? So you're going to multiply x plus h times x plus h times x plus h. Okay, let's skip that. I believe that you can do that by hand or use Pascal's triangle, for example. It's x to the third plus 3x squared h plus 3xh squared plus plus h cubed and minus x cubed divided by h. What happens next? We know what has to happen in the difference quotient, always. Can anyone remind us the 2 mandatory things that have to happen? Yes, Tony?
You have to get rid of h from the bottom.
That's for sure. And what else? What happens at the top always? All terms without h must go away. Excellent. Otherwise, there is a mistake. Okay, so then, yes. And then what we conclude? What will be the next step? Yes? Yes, you mean factor. What are the keywords in algebra that we talked about? The keywords? Factor, simplify, correct. So I will factor out the common factor, the greatest common factor, which is, it must be at least that. Good. So then what is left and how many terms? 3 terms. 3x squared plus 3xh and plus. Very good. So now I simplify. Can I simplify? What if h is 0? Look, it says h approaches 0. Can I simplify by h? What did we say? I know it was a long time ago, but we said that when we say h approaches 0, we really mean it. We-
That's zeroing for h.
Right, but we said what? When we say x approaches 0, exactly. So please remember that. Otherwise, I have to state restrictions and other things. Good. So then finally, what is left? So this will go to, so the derivative of x cubed, which is the function that gives the rate of change of x cubed at any point, because it's polynomial, it's differentiable everywhere, then what? Is 3x squared. So now we can finally go back and fill it in on the handout. What will you fill in for x to the nth power prime? What would you say? So it's n multiplied by, yes. This is not a proof, what we just did with x cubed. It's not a proof. We just looked at an example. What do you think is going to happen with x to negative n prime? Anyone? Times x to, very good, negative n minus 1 indeed. Okay, good. So now we are on page 2. This was done. Can anyone remind us what is x cubed prime? What does it equal to? Very good, we just did that. Good. Before we look at the exponential functions, I would like to look at the derivative of the square root because I don't want to talk about it later on. I want us to establish a rule now, and also 1 over x, because we are going to use them a lot this semester, and especially in chapter 5 when we go backwards. Okay, so let's look at the square root of x. Now we don't have to use the definition if you don't want to do that. So I want to determine the square root of x prime. X to 1/2 is the same thing. Very good. So the square root of x is the same with x to 1/2. How do I differentiate x to 1/2? Very good. Excellent. Which is nothing else but 1 over 2 what? Indeed. So please remember this. Yes, you can prove it with a definition if you want to, but the square root of x prime, so you can put prime on it. I forgot to put prime on it, I'm sorry. It's 1 over 2 the square root of x. Good. So now let's look at 1 over x. We don't have to use the definition. You can if you want to. If not, if we don't use a definition, how are we going to write this? So what is the other way of writing 1 over x? Very good, excellent. And then? Very good. So this is another very important result. We have to remember this. Good. Before we come back to the exponentials, derivative of exponential a to the x and e to the x, let's practice a little bit. Please choose from here whatever you want. I'm sorry? You want G? I didn't talk about exponentials yet. So let's choose any other problem to practice with, and then we'll go back and, which one? B as in boy. Very good, excellent. So then we have f of x equals x squared plus 4x plus 3 divided by the square root of x. Any suggestions on this problem? Of course, we are asked to find f prime. Any suggestions? Yes, actually how? Yes. This is what I would do.
Multiply
Nope.
the derivative of the top.
Hold your thought. I have to use the quotient rule. Careful. Careful. Yes. Tony?
That's what I was gonna say.
No. We can use the quotient rule, but there is an easier way. Because the denominator is one term. If I had this, then it would have been my only choice, what you suggested. But it's not that. And I want to make, because we know, simplify factor, simplify factor. Those are the key words, right? So what do I do? What is the other way that I'm getting at? We just used something very similar a few minutes ago.
That on there.
Nope, I can't. But this is what I can do. This is what I can do, because the denominator is one term. Remember when I needed your approval on this? When I said I can split this fraction, or I can split this fraction into a minus x over b and x over b, because the denominator is one term. Otherwise, I couldn't have done that. So then, copy the base. What happens to the exponents? Subtract. From 2, I subtract 1/2. What do I get? The least common denominator. Adjustments. 4 minus 1, 3. So x2, 3/2 plus. Copy the base. From the exponent of 1, exactly, thank you. And then finally plus 3 times x to which power? Indeed, very good. Could you have used the quotient rule? Yes, we're going to use the quotient rule on something else. But I wanted to show you this way as well. So finally, f prime of x. What do I do? I'm using, first of all, the derivative of a sum is the sum of the derivatives, because the functions are differentiable, right? Plus 4 times 1/2, which is 2. X to which power? Careful. Careful. Yes. Remember, you have to subtract 1 from the power. 1/2 minus 1. Correct? Very good. And then minus 3/2 x2. I owe you 50 cents, and I asked for $1 more, so now I owe you 3/2. Yes, you can change it back into a ratio if that's what you want. You will factor out x to negative 3/2 and take it from there. Yes, Tony?
You explain that last step again. I got
Yes,
lost.
yes. Where am I? Am I here, from here?
Just where we started writing the derivative.
Okay. Okay, so now remember we are using x to the nth power prime which is n times x to n minus 1.
Okay.
So I bring 3 halves down, and from 3 over 2 I subtract 1, which is 2 over 2, right? Okay, so I have 1 half, and that's how I get this number. And then plus, I have 4, I bring down 1 half, 4 times 1 half is 2, but I have to subtract 1 from 1 half, and then I get negative 1 half. And then I bring down negative 1 half, multiply by 3, I get negative 3 halves, and then from negative 1 half, I subtract 1, and I get negative 3 halves. Is this okay now?
Yes.
Good. Okay, so now let's apply the quotient rule on something like this. We can also apply the product rule and then go back. Which problem would you like to work on? Okay, so let's work on F. And remember what we're doing. Let me refresh your memory. 1 divided by 2 prime will be 1 prime times 2. Again, I prefer the same order, 1, 2, 1, 2, but you don't have to. 1 times 2 prime divided by 2 squared. Okay, so we have 2x minus 4. Everything divided by 3x plus 5, and everything prime. Just give me 1 second to get my